going to say Revit sketchy lines aren't sketchy enough for you. You had to go old school.
No, they're not. They're not sketchy enough.
Bandwidth for this podcast is brought to you by Ideate Software. Be sure to check out all of their great Revit applications designed to increase your productivity.
Hello, BIM thinkers. No, we're not from Switzerland. We're not the yodeling guy that goes up the Price is Right thing for those of you who are old and remember that. We are myself, Bill DeBevick, the fabulous Dana DeFilippi. I got her name right. I'm getting it right. I got it, I think. We'll see what happens next time.
That's perfect.
And the storm himself, Carl Storms.
Hello.
Hello. And today we have a very special guest, Brian Ringley. He is with a great spot, a great place, and I'm going to let him introduce himself to tell us all about it. So define yourself.
Define myself.
Define yourself.
I am the construction technology manager at Boston Dynamics, formerly of the AEC industry. Worked as a design technology specialist at Woods Bagot for several years, and then was a construction automation researcher at WeWork. That's where I started getting into field robotics, and that's what ultimately led me down the path to Boston Dynamics.
Wow. So what do you construct at Boston Dynamics?
They don't let me touch the robots proper, but...
You can try to kick them over, though, right?
No, we don't do that anymore.
Oh, okay.
Yeah. It turns out that when you do that, then people come up to you at conferences and drop kick your robots with no warning, which is actually fine. It's fine for the robots; they can handle it, but it's not good if somebody's next to the robot. So we're trying to be nicer to the robots and encourage everyone else to be as well.
Okay. So that now that I've squirreled you.
I do love a good episode of BattleBots. I'm not going to lie.
I do too.
Maybe someday we'll release our jousting footage.
Oh, that would be cool.
Yeah.
I wonder how Spot would do at BattleBots.
Really well.
You think?
I'd like to think that Spot would win at everything.
I don't know. I think that spinny one would knock a leg off.
You got to attach a hammer, just something that couldn't come down on him.
All you need to win is a bone that it throws.
There you go.
So it throws the bone. Spot goes after it. Your robot goes behind it and knocks it over.
There you go. We did do an image training set for machine learning on dog toys.
Oh, yeah?
Yeah, that's how we trained Spot to fetch with its new arm that's coming out.
Oh, that's right. I saw that on the interwebs.
So it can recognize the toy, and then it can also recognize people, so it knows where to take the toy once it's got it.
That's pretty cool.
So cool.
Yeah, but I guess I didn't answer what I actually do there.
Yeah.
which is I product manage for the construction industry. So I work primarily with general contractor customers. Yeah, we have an early adopter program. And we work with these customers on site to take what is a really cool robot and make it useful for their business case.
I could see having Spot go around at night and LiDAR the whole spot so that you can see what actually changed during the day.
Yeah, people are really excited about the autonomous laser scanning. I think if you've ever scanned a job site, you know that it's mostly like setting up a tripod and then trying to like hide behind something while you play on your phone while the scan is captured. So it can be quite dull.
Yeah, and Spot doesn't care.
No, Spot does not get bored.
No.
The other cool thing about using a robot to do a scan is it knows its position and orientation when it took that scan.
Mm-hmm.
So it can actually help automate the registration process. So you're not only automating the data capture, but some of the post-processing of that point cloud as well.
So how are you doing that in a building, though, where GPS doesn't work?
Yeah, so it's relative to Spot's body in the building.
Okay.
Yeah.
Oh, okay. And then you don't care. You just find a known spot and go from there.
Yeah, exactly. So you localize Spot to start what we call a mission to a fiducial. So you could put that fiducial somewhere which you could call your like local survey origin,
Mm-hmm.
and then as long as you know the translation to wherever like your BIM project origin or whatever other system you need to transfer to, then you can superimpose those things.
That's cool.
Yeah.
What's the craziest place Spot's been?
Oh gosh, that's a good question. I've only been there since December, so there are people with way better war stories than me. I know we've done some exotic stuff like offshore oil and gas platforms. One
Well,
of
that's
the
scary.
yeah, it's very
Spot could
isolating.
Spot could make one wrong step and Spot's in the ocean.
Yeah, that's right. They don't have the same rules about barriers around stairs and things that you would see on a construction site. And actually,
Right.
one of the things we really had to invest a lot of time into to work toward 2.0 was Spot was doing really well on standard rise and run stairs, but we had to train Spot to understand graded floors and graded stairs as
Oh.
well, which are very confusing to a robot.
I bet.
Yeah.
What about anything with, I know you guys do some stuff with public safety, anything with like crazy radiation exposure and things like that?
Yeah. Spot has been in nuclear facilities and
He's probably still there.
yeah, and is now there forever.
Yeah.
But the thing about facilities like that, and this is true to a lesser extent, but still true of like electrical substations, is it's extremely expensive to power down those facilities in order to run the required inspections. So if you can send a robot in there and not have to power down that facility, like the savings of that one day alone, would justify the cost of the robot easily.
That's fascinating. And I'm sure that there are so many other applications where Spot just saves us not only money and time, but just so many other things that where humans can't even go.
Yeah. And I mean, it's interesting because, automation, I think, has historically focused on, changing the environment to accommodate automation, like what we see in factories or Amazon warehouses. And, a big goal of Boston Dynamics robots was to create mobile robots that could go into human purposed environments, essentially go anywhere a person can go. And once you do that, then you start to ask, like, are there places people can't go, and often that's just a question of safety, just the ability to take people out of hazardous spaces, for example on construction sites, like confined spaces. But yeah, then you wonder, like, well, what else what else can this amazing little machine do? It seems like the potentials are almost limitless as you advance the software.
I know it can be an actor because I have seen it on the silver screen.
Oh.
Where did you see it?
There's a TV show from ABC called Emergence, and it's about AI and all that sort of stuff. And they break into one scene, they break into this top secret layer, and it's the security guards. There's two of them that walk around the building and chase them out at the end.
I'll have to check that out. I know that an early version of Spot was on Silicon Valley. Actually recognized a colleague in that scene. Yeah, and Spot's been in the entertainment industry. I mean, there's like a wide ranging things. We did some stuff with Cirque du Soleil, and we did some stuff with. We've been working with this group called Agency, spelled AI, Gency, and they have a very crazy TikTok account where they do really funny videos of Spot, like wearing hoodies or with giant googly eyes or just doing funny dances. But the dancing is actually a big part of how we research how robots move. It's something that the founders call athletic intelligence, and it's one thing to make a machine achieve like an obstacle course or do a particular dance move, but then when you look at human athletes and dancers, there's kind of a stylization to that and an elegance and a smoothing of those motions that isn't easily replicated with the baseline code that moves robots. So we've been studying that a lot and learning from those professionals to build more robust motion into our robots. And then that stuff filters its way down from the R&D robot Atlas, which is the bipedal that does backflips and parkour. But some of that stuff makes its way, down to Spot so that customers can benefit from that. So Spot doesn't slip on a construction site. Might have come from a dance move at some point with Atlas.
I guess you do look like you're dancing when you try to recover from slip.
It's true. Well, even slipping, that was another thing we were working on with 2.0 is it's easy to recover when you're slipping by like flailing your legs wildly around you. But it turns out that that's not a safe thing to do around construction workers and equipment. So we built better like slip recovery behavior.
Oh, okay.
That's calmer. Like there's a lot of stuff that Spot does now that's just like calmer, so that it doesn't cause a ruckus, and that's how we can make it safer so that it can be in these environments around human workers.
So is there going to be a spot on the moon or on Mars?
I was having this conversation with some architects that work on space robot stuff, and Xavier de Castellier, who used to be at Foster's and is now at Hassel, has been doing some interesting stuff with robots on Mars. And I had a conversation with him, and I don't actually think that it's the right morphology for space. It seems like space is all about in situ resource utilization and really, really simple redundant systems. Kind of you almost want to make it really dumb but really robust, so that if like your comms fail or you can't get in touch with the robot or it slips or something, that it doesn't fall over. I just can't imagine a legged robot. It's kind of like once it falls over into an unrecoverable state, then it's just space garbage forever.
Right, then you're done.
Yeah, so I think there are a lot of like enthusiasts of space robots at Boston Dynamics. I don't think we're convinced that like legged robots are going to have a place in that world.
Yeah, at least without somebody that can turn it over.
Yeah, when we send people there. Well,
Yeah,
it can turn itself over, but
Uh-huh.
Things can go really wrong in space. So I feel like it could go beyond a simple like tip over and fall recovery.
Well, things go really wrong in the laboratory as well.
Yeah, that's true. And on construction sites.
What about a mini Spot?
An even smaller one? I mean, Spot is actually
like tiny.
I mean, Spot is actually a miniature version of earlier quadrupeds. I mean, that was one of the conversations about like how do you take a robot that's been like a research robot for DARPA, for a decade, and turn it into something that could go into somebody's home and load their dishwasher, or go into a construction site and perform a scan. And it's obvious that, and also to bring costs down and to create something that you can manufacture in large quantities. So yes, Spot's already been miniaturized, and I don't know if it would make sense to go much smaller. I mean, it's a really interesting question, because I think about a lot of customers want something bigger because they assume that it would be more useful to carry more stuff on its back.
Oh, okay.
But if you think about the way that we move materials on construction sites, there are a lot of really constricted areas. So I think you'd shoot yourself in the foot if you went too large with the robot, because then you couldn't really get everywhere. And really, the point is to have that mobility where you can get anywhere.
Yeah, like if they're small enough and inexpensive enough, then you just buy 4, 5, 6, 10 of them instead of one big one that hold 10 things.
Well, I'd like to think there's a future in which you'd have just as many different types of robots on the construction site as you have different types of people and laborers. So like maybe there are some smaller drones or miniature robots.
Right.
I mean, Dusty Robotics has developed a really interesting layout robot, which is essentially a printer on wheels. It's very purpose built. It's very compact. Like there's no reason that couldn't be doing layout, while Spot's doing data capture. And I would love for them to be able to speak to one another too, and start the network on the job site.
I can see a case for Spot delivering part to like an electrician or a plumber or what have you.
Yeah.
Or it would go into the room and inventory what he's got, and then go back and say, okay, he's got 10 of these and 5 of these and whatever of these. And then someone fills him up, or he even gets the parts and brings it back. automatically, where the worker doesn't have to say, "Hey, Spot, fetch me a this." It would know what it would need.
Yeah, I mean, anyone who's been on a site knows that it's like a huge pain when you're like, I need that one tool. It's back in my
Right.
job box. It's like 2 floors down, but the
Uh-huh.
elevator's out of service. To have a robot that could, use RFID or a similar technology to go fetch stuff for you, but to also maintain an inventory would be very useful.
I can only imagine the amount of time wasted traveling the site. When we
It's like 95% of the time.
Because when I had to do a photo study for Cosmo from either tower and from 6 other vantage points of the pool during the day to see what the shadows did, it took all day for me to get probably 12 shots from each vantage point.
Yeah.
Just to walk this, it would take a half hour just to wait for the elevator.
Yep.
To take you up the side of the building.
Just to clarify, Bill, you're speaking of the Vegas resort, not the drink or the magazine.
Correct. So it would take a good half hour from when I got to the elevator to get to the 50th floor.
So did you enjoy a Cosmo while you were waiting?
I really needed one after all of those elevator rides on the outside of the building.
Nice.
I did not enjoy that at all.
Vertical circulation is a huge challenge, and they're also just like massive construction sites too, like convention centers and sports architecture.
This was 4 million square feet.
That's a lot.
It was a big building.
Yeah,
still is a big building. Still there. So yeah, I can see Spot doing that. I can see Spot doing LiDAR at night to see what's changed, or even just send Spot out to the site during the day and all night just to go and get everything out of an existing building that you want scanned, especially if it can figure out how to open doors.
Yeah, I mean, you might as well run it 24/7.
Yeah, well, as long as the battery will last.
Exactly. Yeah. So, yeah, and like as you touched upon, I mean, laser scanning and 360 photo collection have been the really big use cases for construction customers. And we do talk, we're in the early adopter program, and we're hearing a lot from customers that, more robust autonomy is what's going to lead to a bigger ROI for us. And, which we totally get. So we look at the things that, block autonomy, and, stairs are working really well. The ability to go up and down stairs so that you're not limited to a single floor at a time. The arm coming later this year will deal with most standard doors. Some people look at the door opening video on YouTube and they think that was something that was kind of explicitly programmed, like the way you would program an industrial arm. But it's actually machine vision.
Oh.
So it's looking at the door, it's recognizing the type of handle so that it can kind of sense how far away it is and also how to grasp it. And then it's going through kind of a series of canned motions that it knows will get its body through.
And it needs to know to push or pull.
Exactly. Yeah. And, there's still going to be edge cases like temporary plywood sliding doors and all the kind of weird barrier stuff that you find on construction sites. But I think it's a good start for most environments. And then self-charging is also a really important thing that we have coming out, which I don't really have a date for that, but it's well in progress. And we're really excited about that one, because all of a sudden, you can hot swap the battery right now, but that means that you have to kind of be there.
Right. Or you have another spot, bring a battery.
I suppose you could. I wonder if anyone's made that video yet.
I don't think, well, I don't know. It depends on how much the LiDAR thing is. If the LiDAR thing is relatively inexpensive, then it would just be cheaper to buy 2 spots, and one picks up where the other one left off, or they both go at the same time.
You just keep getting more spots to do
right
on the first spots you got, and it just goes.
I think he's looking for a commission.
No. Samples.
Samples would be cool. Brian, you mentioned the idea of, Bill started it, scan the site at night. So drones or UAVs are very popular, but there's a ton of restrictions about they can't fly over a site when there's people there. They can't take pictures when there's people there. So what's the difference between a drone that flies and something that can record video, audio, all that stuff and walks around? How does that get by those rules, or does it?
Yeah, I mean, UAVs have airspace restrictions, obviously, and I think there's still a really great tool for getting the exterior scans and shots when you're doing ground up construction. We're not subject to any like federal aviation stuff because Spot doesn't fly yet. But we found that Spot's able to carry things that drones can't carry, and like I said, when a drone falls, that's a tough recovery. But Spot is built to take a beating. Spot's built to tip over, fall downstairs, and get itself back up and continue on the mission.
And so I guess the expectation of privacy isn't the same with Spot because there's this bright yellow thing walking around making a bit of noise, whereas a drone that's 400 feet above, you might not know that it's capturing the workers on time. Is that kind of the idea there as well? That because it's so visible, we don't have that same expectation of privacy being on the job site?
Yeah, I mean, I think that's a good question. And the base sensors, the depth cameras that Spot uses, aren't really high enough resolution to be able to identify people. It's really low resolution information that's just used for navigation, and it's basically throwaway data that doesn't really persist for any usable reason. So it's really kind of we have these conversations with the customers, which is, what are your construction site operations? What are your concerns? How do we make this safe? How do we respect everyone's privacy? But ultimately, the customer is the one who's putting on the laser scanner, who's putting on the camera. And those customers have a lot of experience with capturing data already. The reason they're talking to us about Spot is because they're interested in data capture. They understand the value, but whatever systems they have, whether it's static cameras or a wheeled treaded robot or a drone, just aren't cutting it. And they're looking for additional mobility. So we try to really just focus on the mobility problem, and then work with customers to understand how to make it easy for them to add what we call payload to the robot.
That makes sense. That which leads to my next question, and you addressed this a little bit when you were talking about the upgrades that are coming to Spot 2.0. But at AU last year in November, there was a couple, I think, Spots walking around, but the most notable was Faro had one that they was all over. It was the darling of the show, and got to see it live a couple times. But you really noticed that at that point it wasn't operating under AI. Obviously, 10,000 people wandering around. It's not really a conducive environment to do that. But what is its functionality when you do get to go on job site where it is doing the autonomous work?
Well, it's not really using AI. It's definitely not using any kind of machine learning or image-based AI for its autonomous navigation. It uses its onboard depth sensors to perceive the environment around it, and then its proprioception, its sense of its own joints and body, to perceive a space and then to move through that space. So the way an autonomous mission works in practice is the end user pilots Spot, and you can use the default joysticks on our tablet. You can use custom software. We even have some scripts to use an Xbox controller. And you walk Spot through the site, and then you set waypoints. And those waypoints are places where you say, I want you to pass through this location. And then you can also add actions there as well. So when you pass through this location, I want you to pause and take a high resolution laser scan, or I want you to capture a 360 photo. Once that's been recorded, you play that back, and then Spot will repeat that exact mission while exhibiting obstacle avoidance. So if somebody, moves their job box in the way, or there have been minor changes to the site because construction work has been performed, or a worker kind of gets in the way of Spot while it's trying to move, Spot will safely move around those things, or if they're low enough, up and over those obstacles. And in terms of ideas like facial recognition and things like that, everything to Spot is just obstacle and terrain. There's no semantic knowledge by default. There are developers who are working on adding those capabilities, and that's the point, is it's a framework that's extensible. We started to change that with things like stare behavior, and then the arm will represent a whole new host of technologies. But Spot does actually recognize stairs as stairs in order to be better at navigating those, because that's always kind of been the Achilles heel of a legged robot is falling down the stairs. So it's really important that we get that right.
Yes, I guess so. And I guess you make a good point that we shouldn't make the broad sweeping generalizations when I say AI. For I think that you're right. It's autonomous, and from what you've explained, it really is a lot like a UAV where you put in a flight plan, it follows the flight plan, it does that, and then it's wash, rinse, and repeat
Exactly.
through
Yep.
that. So that's actually really cool, and it gives a little more accountability is the wrong word. I can't think of the right word, but it doesn't seem quite as scary as people might say when you put it that way. That we give it a path, we train it to do that, and it follows that same circus. So I don't have to worry about it doing anything unexpected during that. It just knows to follow that course, and if somebody moves a job box out of the way, it knows not to take this expensive piece of equipment into the job box, but to avoid it.
That's right. Yeah. It only does what you tell it to. And even some of the obstacle avoidance behavior is intentionally constricted a little bit. So if you could imagine that if a job box is like 4 feet wide, that's probably safe for Spot to step around. But if you intentionally put up a barrier that's 10 feet wide or 12 feet wide, do you really want Spot to deviate that far? Like you're starting to get into territory where you might be introducing unsafe behavior. And when it comes to providing something useful for people in construction, safety is priority number one. So there are things that Spot could do in terms of making its own decisions, so to speak, in terms of obstacle avoidance. But you have to weigh that against safety.
And that makes sense. Dana, you've been awful quiet. You must have a question.
Yeah, this is so fascinating to me. You guys know that I can't get into the inner workings, but playing with robots and that kind of things. I mean, I grew up with brothers. So to me, I'm so fascinated. I just can't get enough of it. So speaking of what you guys are planning on doing with Spot, it seems like you guys are currently doing telemedicine, but you're moving into the kind of remote vital inspection and even disinfection with UVC light and other technologies with Spot SPAC and doing other things in this crazy time we live in. And that also is super interesting. And I've been watching the news, probably like many people, just trying to figure out what is happening in the world because nobody knows, right? And you see these new technologies coming out where they're reading body temperatures and things like that. But you guys seem like you actually are planning on going past that.
Yeah, well, it was like everybody else, which was just like, well, how can we help? And we were making masks, and people were at home like sewing masks, and everybody was like doing their part. I mean, it's a group of people who are really creative and just like to make anyway. But then we were like, obviously, we should see if there's a place for mobile robotics to help. And one thing we wanted to make clear too was that we didn't presume that you needed a quadruped robot necessarily for any of this stuff. So that was kind of the idea behind doing it open source, and also talking with other mobile robotics companies, learning from stuff that Shark Robotics had done, talking with ClearPath Robotics about some of the stuff they're thinking about. So then we just kind of said, okay, we're going to work with this hospital in Boston, Brigham and Women's Hospital. They're going to deploy this. We're going to learn from these medical professionals about what's important to them in terms of minimizing their exposure to the virus. And then we're just going to open source everything because we think that, we're probably not the best solution for every scenario here. So we'll just share it, and we'll see if other, if a wheeled robot can do it and it's cheaper and works better in a particular environment, then great. Then we've moved the needle.
Yeah, super fascinating.
It is really fascinating. Carl, you got to have something else.
I do, but it's not Spot related. And we've had a lot of great Spot talk. Love Spot. But I wanted to take an opportunity to thank Brian. And Brian's going to go, what the heck are you thanking me for? But I wanted to thank Brian for getting me into podcasting. The very first podcast that I ever listened to was episode 6 of the Design Lies podcast with the Dynamo folks on there. I think Zach Crone put it on Twitter somewhere or something. I thought, what is this podcasting? I downloaded it, I listened to it, became a fan of all things Design Lies through there, and that led to being on podcasts. And here we are today recording one with BIMThoughts. So I just
That was
wanted
the
to tip
gateway
the
drug.
hat. It definitely was the gateway drug. So I'd
Yeah.
like to thank you and Zach for putting that together.
Oh yeah. That was super fun. I almost feel bad that that's the first thing that you listen to. Um, like I feel like maybe that was starting off on the wrong foot, but that was a fun episode, right? Because that was we also had, I think, Matt Jezik and Colin McCrone. Like we had, I think, all of them.
Correct. Yeah,
Yeah,
it was Matt and Colin and Zach. It was a barbecue episode or something to that effect. I
that's
can't remember
right.
what it
Yes,
was, but yeah.
yes. That's right. We went out and got barbecue, and then I think we crammed in Zach's like tiny co-working space in Dumbo to record that back when he was running his consultancy Parabox.
Yes, and I remember that because Dumbo always made me laugh. Someone that's never been to New York or Brooklyn for that matter, the Dumbo always made me chuckle.
Yeah, that was like early Dynamo days too. That I think we had gone beyond the orange nodes at that point, but it was still pretty early days.
It definitely was pre-1. It was probably 0.7, but yeah, it was very early on. That's when I just picked it up.
Yeah, it was interesting because I actually I knew about Zach before I met him when I was in grad school in architecture school. I think he had actually he started Designalize as a tutorial website. So I had learned a lot of Grasshopper on my own using his website. And then when I was at City Tech teaching near his office in Dumbo, he was teaching there too. And then we started hanging out together, and I started contributing some videos of my own. And then that's when we decided that, we were always hanging out with really smart, I guess design technology type folks that were passing through New York and like going out and getting drinks with them. So we're like, we might as well record this because we think it's probably a very small niche audience, but an audience nonetheless. And then we did I don't even remember how many episodes we did. We got real lazy at the end. I think there's still like 5 unreleased episodes, which maybe someday we'll release the B-sides.
Nice. But one of the nice things that I like about that is the very relaxed conversational style. You may notice something akin to it today as you're part of this podcast. That no matter who the guests were, that it was it was all the same.
It was a little too relaxed, I think, at times. We didn't always keep it PG, but we were young and foolish.
And that brings me to the next question, off topic or not spot related, is just from your different feeds on the social media. I see that you do a lot of stuff on the teaching front, so a lot of robotic stuff at Pratt, I think it is.
Yeah.
So what is your feeling on the teaching side? I had spent 8 years with a reseller where I taught all the time, taught at a local community college myself on the Revit side. There's sort of something magical about getting that aha moment when people are really learn something from you. So I'm just wondering what your thoughts were on your journey through teaching.
Yeah, and curiously enough, this is my last semester, at least for a while. So I can focus on this new job with Boston Dynamics. But yeah, I've been at Pratt for a while, teaching design courses, but also focusing on technology courses like industrial robotics and Grasshopper stuff. And it actually started. My teaching career started kind of by accident, which was I graduated during the recession and no one would hire me as a designer. So I decided that I was at the University of Cincinnati and we had a really amazing digital fabrication facility that up until that point had really only been used by the industrial and product designers. So I had some conversations with the staff and faculty there, and I said, this would be really interesting to open this up to, architecture, interior design, fashion design. We have an interdisciplinary college here. We should all kind of be collaborating on this. So that's how I got my start. And it was my very first class was like creating custom CNC toolpaths in Rhino. And then I remember I had a guest critic come through and she was like, why aren't you using Grasshopper for this? Like you're like painstakingly extracting ISO curves, like with manual Rhino commands. And then I was like, tell me more. And then I was like, you can automate everything. And then that became a lifelong obsession, which is like doing the least amount of work possible.
Do you remember the first thing you automated?
Oh, it was toolpath extraction. I was obsessed with like this. I'm sure you've seen stuff like this where you make patterns with the CNC machine by intentionally like leaving the cusp behind of the stock.
Mhm.
So I was like just fascinated by that, and just the fact that you could directly drive the machine operations with the digital model. And this idea has, I think, persisted in my work. And, it became like, oh, now how do I have BIM information, but I want to send that directly to a manufacturer. And maybe I don't want to make shop drawings. Maybe I want to send that directly as machine code. And then now, like, I have architectural and construction data in my models. Can I use that to drive robotics? So I think this idea that you could use this model data to drive the act of making and production and digital fabrication of robotics has like always been like a core interest of what I've done. So that was kind of the common thread, I think, through all of my teaching from that point forward.
So the learning, the ability to automate and to do that was your gateway drug into the teaching world.
Yeah, I think so. Yeah, I mean, I remember all the way back to grad school, like even before even before Grasshopper was a thing, right? So it was like explicit history in 2008. But even before that, I remember a professor named Glenn Wilcox at the University of Michigan posted a video tutorial, and it was like using isocurve extraction from Rhino surfaces and then exporting those as IGES files and using those to drive CNC toolpaths. And that like blew my mind. So then I was really into CNC machining. And yeah, speaking of gateway drugs, that led to industrial robotic arms. So when I was at City Tech, I got my first ABB robotic arm and taught a course with that. And then the industrial arms kind of led over time to the idea of mobile robotics and field robotics. So when I was a construction researcher at WeWork, I got to build some of our own basic like wheeled robots from research kits, but also got to work with AMRs, like factory robots or platform robots on wheels, and then on into the world of legged robots.
Sorry, did I catch you correctly saying that you bought your own robot arm?
No, we got it at, I mean, the first
Okay,
robot,
okay.
no, that is not, those are not yet at my price point.
We can 3D print one.
I mean, I definitely have a fantasy about, buying arms for like a garage someday. He says from a tiny apartment in Brooklyn, where I can barely have one toolbox. But yeah, I mean, there are.
You could get a tiny garage and a tiny little robot arm.
That's true. There's really a theme of like tiny robots in this.
Well, I've been working on Matchbox cars for so long.
Yeah, they actually a group of students at Stanford released something called the Pupper, which is like a really tiny, cute quadruped. It's like, I don't know, like the size of a laptop. It's so adorable.
Well, we're going to have to get you back on, Brian, when I get the rover started.
That'd be great.
So we can geek out on what I don't know about robots.
That'd be amazing.
And what I figured out myself. Maybe we'll have to do a series on it if you're game.
Yeah, and then we can make like a Dynamo plugin that controlled it.
Right.
There you go.
Right. Or not. All right, Brian, thank you so much for joining us on BIMThoughts. It's been a blast.
Yeah, thank you for having me.
And I'm sure that this hit the spot for most people.
I was waiting for the pun.
Yeah. Well, I was Johnny on the spot.
We better end this.
Yeah, he'll just keep going.
Yeah, that's right. All right. I'll hit the spot this time.
Thanks, Brian.
Thank you.